Good day, everyone. I'm Tong Qiu from Shenzhen University, and it's my honor to speak right here and to introduce my study. And today the topic is a novel model for analyzing assemble joints of prefabricated underground station and its application. Here's the outline, the introduction, model construction, and application. And the background is today modern prefabricated underground structure has emerged, and so many novel assemble joint has been using this underground structure. When a multi-parameter problem of assemble joint has emerged, and including the joint morphology, the joint size, interface property, axial force, fasteners, and these all kinds of problem. And we fabricated focus on the prefabricated underground stations, and it is a new style of traffic infrastructure. Use a prefabricated structure and assemble construction and solves the problem of CI cast in place construction. And multiple and novel assembly joints, and they were developed for all kinds of underground structure. They use welding and bolt and rebar precious assembly. And this assemble joint, they were rooted from thinner mortise assemble joint. And to talk about their traditional models of assemble joints, we mainly have stiffness corrected, continuous model, multi-hinge model, beam shell spring model, experiment fitting empirical model, and finite element analysis model. We build a new models specificated focus on the solid discontinuity, because when the joint is bending, we can see the interface right here. Here it's no continuous solid. So the solid discontinuity of assemble joints is the main problem of our no-volt theory model. And the solid continuity model is inappropriate for the joints. And interface contact behavior is difficult for hinge spring to reflect, because the contact behavior here is complex. Under fitting empirical models, that has limited application, because when the parameter of the assemble joint is complex, the fitting is not right. This model is hard to review the mechanical of the assemble joints. FEA model is difficult for parametric research, but it can really reflect this problem and solve this problem. We focus on the parametric research. So the theory model of assemble joints remains to be studied. And model construction. To talk about the background of our novel model, the joint interface contact model, we focus on the solid discontinuity, because when the joint is bending, we can see the gaps may created. We can see an incompleted contact in the tenant's interface, and you can see the C2 interface they may open. So we take a C1 interface, for example. Just before contact, the compressive force of a C1 interface is zero, because there are gaps right here. And when you contact, the compressive force occurs, but this force is generated from the contact, not from bending. So the solid discontinuity and the contact behavior of unstable joint is a main problem of this model. And so we treat the interface as element for the joint model. We divide the interface for two kinds. One kind is a C1 interface, and the second kind is a tenant interface. We built two interface contact formula for these two interface. And we also created three joint models for constructing gypsum. The joint geometry model, it reflects the joint size morphology, and the joint material model, it reflects the interface property. And the force equilibrium model, you refer the fastener mechanism and the axial force. And here's the formulas to run background to analyze the force equilibriums and reflect the joint mechanical property. And we build this model on the MATLAB platform. You can see we can input the parameters right here that reflect the parameters of three joint models. And this calculation, the backgrounds, and we run JSON, it output the result and displays the moment deformation relationship, the curves right here. So it is easy to assess the joint performance of multi-parameters. And here we use multiple different experience to validate the JSON. So we can see the welded joint, gluted joint, three different joint experiment. You can see three curves right here that fit well. And you can see the segment wall joints, and here you can see the segment joint of tunnel and the joints of POS. You can see they all fit well. So JSON can reflect the multi-parameter effect of their assembled joints. And we use it on a real project. And the application is in Shenzhen Metro. We solve the problems of the casting place diagrammed walls. You can see when the wall put into the construction, it has generally has safety, quality, pollution, and other issues. But we use a new product, the prefabricated thin wall diagram walls. We call it a PTDW, and use prefabrication and assembly construction technique. So you can see it's a high quality and efficient green products. And here's the project right here, Citation. It uses PTDW, and the most important problem is how to assemble this PTDW together. And this study focus on the transverse assemble joints because it is the most important joint to determine the mechanical properties of the diagram walls. You can see the construction process and techniques right here. You can see that we use an intelligent platform. You lower the PTDW into the story change, and we fix it right here and assembly above the ground, and lower it one by one to the trench and build the PTDW, the whole wall together. And we perform a pure bending experiment on the welded joints. Here is the specimen design. You can see we use angle steel on the assembled joints, and we put it together and weld it together, and it becomes a welded joint specimen. And we have fabricated this specimen in the factory, and we assemble it together and transport it to the laboratory to experiment. All this process is to guarantee the quality is the same as the actual project. So you can see we use a 3D loaded system to perform the pure bending experiment. You can see the displacement sensor, the strain sensor, all kinds together. And here is the specimen setup. And you can see it's pure bending and it's fixed right here. Here is the force status. Use the camera, all kinds of stuff to collect the data. And we performed, here's the results of welded joint experiment. We performed two groups of experiment, one group without axial force and one group with axial force. And you can see the group without axial force, the section was damaged first. You can see the steel rebar, the rebar has a fractured right here. But the joints remained well. But the one with axial force, you can see the joint damage phenomenon right here. You can see the joint opening and the cracks right here. And we also collect all the data into two groups, crack development and joint opening development. You can see the axial force really help to restrain the crack and the joint opening. So there are sections and the joint and they damage together. And you can see the strength development, the lateral strength right here, it does not conform to the flex section assumption. And finally, we get the moment rotation curve. And we also perform the JSON to validate and assess the joint experiment. We input all the joint parameters into JSON, run all the calculation in the background, and get three curves. We use three kinds of fasteners for comparison. Weak fastener, just like gluted joints, limited fastener joints, just like bolted joint, and strong fastener joints, like welded joints. You can see their fastener mechanism is significant to maximize the mechanical property of the assembled joints. And also you can see the if you weld the GSM result and the experiment results. And you can see the welded joints, and they are not easy to open. And you can see the experiment right here. It's not easy to open, even when it was damaged. And so it ensure the dryness and closure of underground space. And the welded joint scheme was adopted in the project based on the gypsum assessment results. So in summary, gypsum were validated using multiple joints experiment, and the moment rotation curves of gypsum fit well with the text result. And gypsum can reflect the multi-parameter effects of assembled joints, including the joint size, morphology, interface properties, axial force, and fastener settings. And the text showed that the deformation of the assembled joint does not conform to the flat section assumption, but it related to the interface contact and fastener constraint. So this property is the solid discontinuity that we focus on this study. And the welded joint is not weak link of the assembled component, and the welded joint have higher bending properties than the sections. So this solves the problems of early damage of assembled joints and a component. And gypsum has been successfully applied in the Shenzhen method. So here's my presentation, and thank you for your listening.